boys and girls, and welcome to another session of SEA Time. I am JACQUELYN PARIAG, your tutor for today. Today, we are going to look at the topic of division. Before we do that, however, I would like to ask you to quickly get some writing material, maybe a notebook, an exercise book, and a pencil before we begin. That way, you can work along with me with the problems, and also you can take your little notes that you may need to as we go along. Okay, so we are going to begin talking about division. The first thing that will come to your mind is long division. And sometimes you find that long division method, it's a bit difficult. But we're going to leave that method alone for now, and we're going to explore some ideas around division. Before we begin, let's look at what our learning outcomes will be for today's session. Today we want to look at dividing 2 and 3 and 4-digit numbers by 1 or 2-digit divisors with and without remainder. We also want to look at the remainder and interpret that remainder in relation to the context of word problems. Before we begin, I would like to ask you some questions. First of all, do you know what are the 4 basic operations in mathematics? I am certain that you knew. I'm certain that you do, because you have been using them all the time in primary school. So, think quickly. Let's see what is our first operation, addition. And there is our addition sign. And what is addition? What does addition do? When we add things together, we join groups, and sometimes we get more. So addition is one of our operations. Can you tell me another operation that we have, that we use? There it is, subtraction, and that's the sign, the symbol for subtraction. When we subtract, we sometimes get less than the original amount. Our next operation is multiplication. In multiplication, we build sets of objects. We build sets of numbers. We get more. And then finally, we look at division, which is our 4th operation. And these are our 4 operations that we have been using. You can use them, and they're not necessarily in the order that is given there, but you can use them throughout your problem-solving activities. Sometimes it might require that you even begin with division. Now, when you look at division, I want you to look at the symbol for division. And you know, when you have the time, you could do some research on where that symbol came about. That symbol is called an obolus, and it was used way back in the 16th century by a very early mathematician. Actually, the symbol was first used for subtraction. If you look at the symbol, it resembles the vinculum of a fraction, with the 2 dots probably being a replacement for numbers. So we're going to look at division and fractions at some point and talk about that. Right. Before we actually get into speaking about division, I want to ask you some questions, because I want you to begin to think about division. Our first question. What does division mean? Our second question, what happens when we divide? Our third question, what are some words associated with division? What are symbols associated with division? And we just saw the division symbol, and there may be others. And the last question there, is division related to any of the other operations? So during the course of our lesson, we're going to come up with the answers to these questions. So I'm not going to tell you them now, but I would like you to think about them as we proceed with the lesson. Okay, so we are going to begin with 2 problems. And I'm going to put the 2 problems up on the board. These are our 2 problems. We are going to explore 2 types of division problems. Okay, and like when every time that we are doing problem solving, we want to go through those problem solving steps, the Polly's problem solving steps, because we want to try to understand our problems. So let us read and understand the problem. Problem 1, Mommy packed 30 cupcakes into 5 boxes. Each box has the same number of cupcakes. How many cupcakes are there in each box? A very simple question, and with very simple numbers. We know how many cupcakes Mommy has. We know how many boxes she has. What we do not know is how many cupcakes are going into each box. There is one important fact that we do know about the cupcakes, and that is the same number is going into each box. In our second question, Mr. Sam has 30 mangoes. He makes heaps of 5 mangoes. How many heaps of mangoes will Mr. Sam get? Okay, as you look at the question, you will see the numbers are very similar. The numbers are very similar to those in the first one. We know how many mangoes Mr. Sam has. We also know that he's making heaps of 5 mangoes. What we do not know and what we are trying to find out is how many heaps of mangoes will he get in the end. What we are going to do now to solve these problems is to make models for both of them. And that is just one of the problem solving strategies that you can use when you're solving problems on your own. So we are now going to model the first problem. Okay, let us look at problem 1 again. Mommy packed 30 cupcakes into 5 boxes. Each box has the same number of cupcakes. How many cupcakes are there in each box? So here we have the model of that problem. So I have my 30 two-sided counters here that represent the 30 cupcakes, and I have my 5 boxes represented by these rectangles. So I am going to take the cupcakes and share them equally in the 5 boxes. I don't know how much I'm going to get, so what I will have to do is to share it one at a time. So I'm starting with my 3rd cupcake, putting the 3rd cupcake in each box. So far I have 3 in each box. Now I'm starting with 4. Putting 4 cupcakes so far in each box. So there we have it. We have shared our 30 cupcakes equally in 5 boxes. And if we look at each box, we see that there are 6 cupcakes in each box. This is an example of fair sharing or partition sharing. In this case, we know the number of groups, which are the boxes. What we don't know is the number that is going, the number of objects that is going into each group or each part. So that is why it's called partitioning or partition sharing. It's fair sharing because we have equal numbers in each of the boxes. So this is an example of one type of division. We continue now with looking at another type of division, and we will look at problem 2. Mr. Sam has 30 mangoes. He makes heaps of 5 mangoes. How many heaps of mangoes will Mr. Sam get? So here we have the model of the problem. We are starting with our 30 mangoes, and they are represented by our green and yellow blocks. In this case, Mr. Sam makes heaps of 5. So I'm going to take 5 of the blocks at one time, and I'm going to make my first heap. And there's a second heap of 5. And the third heap of 5. Fourth heap of 5. There we have it. All our mangoes are placed in heaps. So how many heaps do we have? 1, 2, 3, 4, 5, 6. So this is another type of division. In this case, what we did is we already knew the number in the set. We knew we had to place 5 mangoes. What we didn't know is the number of sets or groups. This kind of division is called measurement division because we are taking a measure of a certain size and we are taking it away from the whole amount. Or it's also called grouping. Our first type of division was sharing, fair sharing or partitioning. This type of division, it's measurement or grouping. And why do we need to know this, boys and girls? When you are solving your problems, you recognize sometimes that you need to know which kind of division you are working with. So here we have a picture, or what we call a pictorial representation of the problem we just did with the two-sided counters. You will see our 30 cupcakes here. You will see that they are being shared one by one and they are being put in the 5 boxes. So we ended up with 6 cupcakes in a box. As we said, this is partitive division or fair sharing. In this case, the parts are known. The parts in this case being boxes, so there are 5 boxes. We know that there were 5 boxes. We knew that the 30 cupcakes had to be shared equally, and so we did. And our solution, our answer is 6. So we have 6 cupcakes in each box. How did we write that as a problem? So what we did, we took 30 and we divided into groups of 5. And there we have a number sentence telling us what we did with the concrete materials and also with the picture. So that 30 there is our dividend. And remember we said at the start, what is the language associated with division? So here we meet one of our first words, dividend. And the dividend is that large group that we are working with and that group that we are going to share. The dividend in this case is the number of cupcakes. So we have the 30 cupcakes. We divided this into 5 equal groups. So our divisor is 5. And the 5 there refers to the number of boxes. And our answer is called a quotient. The answer to a division problem is called a quotient, which I'm sure you know already. This is just a revision. So our answer here is 6. And the 6 there refers to the number of cupcakes in each box. So that is problem 1. We'll look again at problem 2. And its representation as a picture. Here we have our mangoes. We have our 30 mangoes, but this time we have grouped our mangoes in 5. So this is grouping. And then we have taken those mangoes and we have put them into heaps and we got 6 heaps. Right, so in measurement or grouping division, we know the number of objects to be measured. We know that we have 5 mangoes. What we didn't know at the time is how many heaps we were going to get. We made equal groups or heaps of 5 mangoes, and then we found out that we got 6 heaps in all. We have used very easy numbers to demonstrate this. But of course, we know you will work with these types of problems with much larger numbers. And again, we have our same number sentence. This time, our dividend again refers to the number of objects in the large set, which is the number of mangoes, and that is 30. Our divisor in this case refers to the group of 5 mangoes. And our quotient, which is the answer, is 6 meaning we have gotten 6, 1, 2, 3, 4, 5, 6 heaps of mangoes. In summary, we can answer some of the questions that we were asking at the beginning. Remember when we asked what division was? Right, division is a method of distributing a large group of objects into small but equal parts. It is mainly fair sharing, but as we saw with this problem, we also have division, which is grouping. But still, even in this problem, we do have an equal number of objects in each group. What happens when we divide? What happens when we divide is we either share in which we know the number of objects in the group, or we share by measuring a certain number of objects, and then we will figure out how many groups we end up with. Is division linked to any other operation? Maybe it is. We put 6 cupcakes in 5 boxes. If I wanted to get back my original number of cupcakes, I could multiply the 6 by 5. 6 5 times. 6 times 5 will give me 30. So there we see that division is linked to multiplication. With problem 2, we can also use another simple approach, which is repeated subtraction. And you saw us doing that with the number of mangoes in the set, which was 30. I took groups of 5, and every time I took a group of 5, and I kept taking it away from the original number of 30. This is a method you can use if you do not want to use division, and it can be used with small numbers. When you get to larger numbers, it may be a little bit tedious, but it can work. So what we did, we started with 30, and we kept subtracting 5 until we ended up with no mangoes. And then we saw how many times we subtracted the 5. So we subtracted the 5 6 times. So repeated subtraction is another way of dividing. So there we see that subtraction is linked to division. We want to look at some other strategies for dividing numbers, and these strategies will work with numbers comfortably, with numbers that are less than 100. We know we have that long division algorithm, but what we would like to do is to explore some other ways that can help you in solving the division problems. One of the ways that we can do this, it was very simple and we just saw it. We can use our multiplication facts to help us to solve division problems. So here we have a problem. This is problem 3. I'm going to read it. Paul saved an equal amount of money each week for 5 weeks. He then had a total of $45. How much money did he save per week? So we want to use our problem solving steps and look at the problem and try to understand the information in it. So we know Paul had some money, he had saved some money. We know how long he saved it for. He saved it for 5 weeks. At the end of the 5 weeks, he had a total of $45. What we do not know and what we are asked to find is how much money did he save per week. One important bit of information in this problem is the fact that he saved an equal amount of money each week. So we're going to use that to solve the problem. What I'm going to do is now use a picture to model the problem. So you can see the problem. I could use my concrete resources as well, but I've used a picture to model the problem. And this is what we should do when we are solving problems. We always try to use one of the problem-solving strategies to help us to see the problem, to visualize the problem. Usually, drawing a diagram is a way of doing that. So here I have modeled a problem, and you can even see the solution right away from the problem. So I have taken the $45 and I have divided it equally in 5 groups, and I got my total of $9 saved each week. So this is a partitioning or partitive type of division, because I knew the parts, which is 5 weeks, and I had to work out how much money is saved in 1 week, which is how much is in the set of 1 week. There's another way we can visualize a problem, and it's called a bar model. A bar model helps us to see the problem, and it makes it easier for us to solve. So that bar there represents the $45, and I would have had to divide that bar into 5 equal parts. And by counting, I would see that each part is $9. So I got my answer there as well. So visualizing a problem also helps us to solve it. But again, we want to look at using the multiplication facts. So this was our problem, 45 divided by 5. At that point in time, we didn't know the answer was 9. What we could have done is look at our multiplication facts, or what we call our times tables, and from that, we would have probably gotten the answer. So here I have my 5 times tables. So if you noticed, I started my table and I came down to 9 times 5. Other word, 9 5 times. 5 there represents the week, the number of weeks, and 9 there, the amount of money he saved in 1 week. So this fact here, I use to solve the problem. So again, we are seeing how division is related to multiplication. If I didn't know how to divide, I could simply recall the fact, and then from the fact, I could see now that if I multiply 9 by 5, then if I'm dividing 45 by 5, I will get back 9. So we want to look at another problem that uses the same strategy. In this problem, 45 balloons were used to make bunches of 5 balloons each. How many bunches of balloons were made? So the first thing I'm going to do is get my diagram that sort of represents or visualizes the problem. So there I have my 45 balloons. I know how many balloons are going to be in one bunch, which is 5. And what am I asked to find? I'm asked to find how many bunches of balloons. So once I draw my diagram, I'm seeing that there are 9 bunches of 5 balloons. So just drawing my diagram has helped me to solve the problem. Again, I can use a bar model to represent it and solve it. So there's my bar model with 5 repeated 9 times. But as we said, we want to look at using the multiplication facts as well in solving the problem. If I could not have drawn the diagram, I would bring up my 9 times tables, as we call it. And I would start looking at my 9 times table to see which fact could help me to solve 45 divided by 5. And there we have it. 5 9 times will give me 45. So if I'm going to divide 45 by 5, my answer is going to be 9. Multiplication and division are usually called opposite operations or inverse operations. You have seen that we can use multiplication and division facts to solve our division problems. So we can build what we call a fact family that will help us solve simple problems where the dividend is less than 100. So I am showing the example with a 9 times 5 is equal to 45, and I get 3 other facts with that. So I have another multiplication fact here, and I have the corresponding division fact. So 9 times 5 is 45. 45 divided by 5 gives me 9. 5 times 9 is 45. 45 divided by 9 is equal to 5. So I could use those facts to help me solve problems. So it's nice to build the fact families. Let's try to find some of these fact families. I have a very simple fact there. 3 times 4 is equal to 12. And I have 3 other facts in which numbers are missing. Can you write the missing number in each fact? I'm going to give you 5 seconds to try to do that, and then we're going to look and see what is the correct answer. Four. 12 divided by 4 will give me 3. 4 times some number is equal to 12. What could that number be? That number is 3. 4 times 3 is equal to 12. And then the last one, 12 divided by 3 is equal to a number. What is that missing number? That missing number is 4. So I have taken a very simple fact and have come up with the 4 multiplication and division facts for it. So this is the fact family. Now, with the number 12, there will be other facts, and you can use those and you can make your fact families. Jot these down, write them down quickly, and when you have the time, you can try these. This is a very fun way of learning your multiplication tables. I want you to remember also that when you are doing your multiplication tables, you can also do your division tables, and it's very useful. It will be very useful when you are solving your problems. And you should try to do tables every day, do a bit every day. So I hope you took those down and you're going to try them later. Right, we are going to look at another method of solving problem 4. And if we recall, with problem 4, we were removing groups of 5 from the 45. So again, we can use repeated subtraction. If we are having problems with division, we can use repeated subtraction to solve this problem. It's a bit tedious, but we can still use it. So we start with the 45, and we subtract the 5 until we end up with no objects left in this set or group. When we count how many sets of 5 we had 9 sets of 5. So repeated subtraction can be used in place of division. And there we are seeing again that division is linked or related to multiplication. We can also use a number line to show division. So here we have our number line, and it's counting in 5s. I'm counting in 5s. I have 3 counts of 5, 4, 5, 6, 7, 8, 9. 9 counts of 5. So I have shown there that I can divide 45 by 5, even on a number line. And my answer is 9. How I got the 9? That 9 will be the 9 loops that I'm seeing on the number line. So a number line doesn't only show us addition and subtraction and even multiplication. We can even use a number line to help us with division. So let's read our problem. There is a total of 87 students in 3 classes. Each class has the same number of students. How many students are there in each class? And again, with our problem, we are going to look at it and identify some of the key information in it. So we are told in this problem, and it's a very simple problem, that we have a total of 87 students in 3 classes. Another important bit of information given to us in the problem is that each class has the same number of students. And the question we are being asked is, how many students are there in each class? Now, boys and girls, before we go on, I want to draw your attention to the word same number, and sometimes we see the word equal, because we do have a context of unequal sharing. So there are times when we are required to share in unequal amounts. But with fair sharing and with grouping, we always have equal amounts in groups or equal amounts of objects, number of objects. So it's a very simple problem. And to solve this, we can come up with a very simple number sentence. So what we are doing is we are going to divide 87 divided by 3, because we know that there are equal numbers of children in each of the classes. Now, how can we do this? Very simply. We are going to use decomposing and the distributive property to help us to solve this. So I'm going to take that number 87, and I'm going to break that into two smaller numbers that which both of them will be divisible by 3. So I'm going to start with, and I can break the numbers up however I want once both numbers are divisible by 3. So I've decided to go very simply with 60 plus 27, which will give me 87. What I'm now going to do is to use the distributive property to help me get to the answer. So I'm going to divide each of these numbers by 3. So there I have 60 divided by 3. And then I have 27 divided by 3. And with the distributive property, I could simply add those answers that I get. Right. So 60 divided by 3, again, from our multiplication and division facts, we know this is equal to 20. And of course, this one is very much easier. 27 divided by 3 is 9. So my answer is 29. So there are 29 students in each of the 3 classes. Right. Is there another way we could distribute 87, that we can decompose 87? So we can divide? Yes, there is. We could break it up into another pair of numbers. We can use the numbers 57, add 30, because both of them are divisible by 3. I could even extend it to 3 numbers. How about if I try 33, add 27, add 27. So if I'm dividing these by 3, let's see what we will get. So 57 divided by 3, add 30 divided by 3. This will give me 19, add 10, which will still give me 29. $33 divided by 3, add 27 divided by 3, add again 27 divided by 3. So I'm going to get 11, add 9, add 9 again. And if I add those numbers, I'm going to get 29. So I'm sure there are many ways we can decompose the number 87 into other numbers that are smaller numbers that are divisible by 3. And we can solve our problem of dividing 87 by 3 and getting our answer as 29. Boys and girls, we are going to look at yet another model for solving our division problems. We are coming to that long division algorithm, but we are again still trying to explore some other models for solving the problem. I'm going back to the problem that we had with the 87 students that was divided equally into 3 classes. And to do the area model, I first have to model the problem for you. I first have to represent the 87. So on the table, I have 87 represented with our base 10 materials. So I have 8 rods, which is equal to 80. And I have my 7 units to represent the 7. One of the things I want you to understand as well is with all of our operations, place value is very important, very significant. So if you are a little bit shaky with place value, you need to do some revision on place value because it will strengthen your use of all the operations and especially division. So I have my 87 and I want to divide this by 3. Now in looking at our model, we will see that I could probably start trying to divide our 10s by 3, and I'm going to get sets or groups of 2 10s initially, 3 groups there, but then I can't go any further. So what am I going to do? What I will have to do is to trade these 2 10s for 1s. So I'll have to replace these 2 rods, which is equal to 20 with 20 units. These are my 20 units. So I'm trying to make an array here with 2 rows of 10. Right, so what I have done is traded in my 2 rods or 10s for 21s. So I now have 6 rods and I have 27 1s. Can I now divide this by 3? Certainly. I already have these rods divided. I have them in 3 groups. I have 27 here, and we know that 27 can be divided by 3. So in each set, I will get 9 when I divide 27 by 3. So I'm going to take 9 of these. And add them to each of our groups of 2 rods. And there we have it. We have shared 87 into 3 equal parts, each part being 29. So we have model the problem of 87 divided by 3. I now want to represent this another way. So to do that, I will draw a rectangle. It's the area model, so I'm using a rectangle. And in that rectangle, I'm going to put in the dimensions that I have. So I have the 3, which is the divisor, and I have the 87. So I'm going to divide that 87 in my model. So I have 80 here, and I have 7 here. So this is a representation of what we have with our concrete resources. And this is called the area model. So I'm going to start with the 80, and I'm going to divide the 80 by 3. So 3 into 80. I'm going to look for the closest number with tens that I can get that will give me a multiple of 3. And that number, boys and girls, is 20. So I'm going to get 60. Then I'm going to subtract that, and I see that I'm left with 20. Which is exactly what we did using our baseline materials. So I'm going to take this 20 now in the tens column, and I'm going to add it to my ones. So the 20, which is 2 groups of 10, is now going to become 20 ones. And I'm going to add that. And I'm going to get here 27, right? And then I could divide 27 by 3. So 27 divided by 3 is 9. So there I have my answer. So I have used the same problem to demonstrate what is the area model. And there are some variations for this, but it's a nice strategy that you can use, and especially with numbers that are less than 100, and even with larger numbers too. I can take this now and start getting into my algorithm, but I'm not going to do the long division algorithm yet. I'm actually going to do the short division algorithm. So I'm going to come here and write my problem like this. Right. And you should know that this is another way of writing a division problem. And this here is another symbol for division, just like this. So we're going to use what we've done here to solve it like this. So we're getting to that algorithm. Right. So with short division, what do I do? I start with my divisor, and I look at my first number. Right? My number is 8, but that really represents 80. And I'm going to divide. Now I know, boys and girls, we like to say 3 into 8. While it is not wrong, we should try to avoid it. So I will say 8 divided by 3, knowing that 8 refers to 80. And I have 2. I could get 2 sets of 3 there. And what I have left is 2. But we know that 2 refers to 2 tens. So I'm going to take that 2 tens, and I'm going to add it to my 7 ones. And this is what we do here. And no, please remember that that 2 here represents 20. It represents this 20, right? And this is our short division algorithm, which I know you're very familiar with. So now I can say 3 into 27, it's 9. And you can use this method if it works for you. If you like it and you're comfortable with it, you can use it. For larger numbers, you may still need a long division algorithm, but you can't use the short division algorithm. Let's read our question. Rhea paid $75 for 6 of the same cartons of juice. What was the cost of 1 carton of juice? And again, we are going to try to understand our problem following our Polyer's 4-step model for solving problems. Let's look at the information that we have in the problem. We know that Rhea paid $75, so she spent $75 for 6 of the same cartons of juice. And we want to find out the cost of 1 carton of juice. Very simple question. So I can set up simple equation for this problem. And I would be able to find the cost of 1 carton of juice, which is what I'm asked to find. And again, I'm going to use decomposition. I'm going to take the 75 and I'm going to break it down into 2 numbers that are smaller and that can still be divisible by 6. So I am going to use 75 maybe because I know what 72 divided by 6 is. So 75 is equal to $72 add $3. And now I'm going to divide each of these numbers by 6. Let's see what happens. 72 divided by 6, and then I'm going to add my 3 divided by 6. So I know from knowing my multiplication facts and division facts that 72 divided by 6 will give me $12. And here I have $3 divided by 6. What is happening there? I do not have a whole $6 to even get 1. So what is going to happen there? It seems as if we have a remainder in this question. So boys and girls, of course you know that in division problems, we sometimes have remainders. The question is, what are we going to do with this remainder? Are we going to discard it? We can quote it as just the remainder of $3. What can we do with it? We will need the remainder because we are trying to find out the cost of 1 carton of juice. So therefore, we need to divide. So it is significant. It is important in solving this problem. So I am dividing $3 by 6. So I have written it as 3 over 6. Now if I come here and I write 3 over 6, what is 3 over 6? Of course, it is a fraction. And I can reduce this fraction to a half. So really, what I have there is half of $1, which is, what is half of $1? That is equal to 50 cents. Or I can write that as using my decimal point as it's represented there. So the cost of 1 carton of juice is going to be $12 add 50 cents, which will give me Add them together, and I'm going to get $12.50 for 1 carton of juice. This is an example of where the remainder is important and it is contributing to the answer. It is also an example of the remainder being expressed differently, not as a whole number, in this case as a fraction. And sometimes we need to do that when we are solving problems. Let's read our next problem. Farmer Pat harvested 278 okras. She packed an equal number of okras into 12 bags. How many okras were left? So we read our problem. Let's look at the information that we have in the problem. Farmer Pat harvested 278 okras. She packed those okras into 12 bags. The other information we have is that in each bag there was an equal number of okras. So do we have enough information to solve this problem? And what is being asked in this problem? We are not being asked how many okras are in the bag, but we are being asked how many okras were left. So therefore, we are being asked for the remainder in this question. So the first thing we are going to do is to model our problem. And we are going to use our base 10 materials to do that. So here I have the number 278 represented with our base 10 materials. So 200, I have 2 flats. Our 7 tens of 70, we have 7 rods. And our 8 is represented by our units. The question is asking us to divide 278 by 12 because we are making 12 bags. By the way, this question is telling us the number of groups we have. We know it is 12. So what we are trying to find out, first of all, is how many okras will be, or how many okras will be in the group or in the bag. And then from that, we can work out our remainder. So we have to divide 278 by 12. So we are doing a division of a 3-digit number now, and we are using a 2-digit divisor. So we are going to model our number first of all. We have our number here, and we are going to try to divide that into 12. Now, if we look at what we have, we will need to do some trading because it's going to be very difficult, as they are here, to divide them into groups of 12. So what I am going to do is I'm going to replace each of the flats, which is the same as 10 rods. I'm going to replace this with 10 rods. This is called trading. So I have replaced my first flat with 10 rods. The second flat with 10 rods. Right, so we have traded in our flats for rods. Now we are going to try to make 12 sets or 12 groups, which will represent the 12 bags in which our okras are going to go in. So I'm going to try to divide what I have here into 12 parts. So far, I have 12 sets of 2 rods. So I have here 12 sets of 20. Right. My remaining base and materials, now I would need to trade so that I could divide that into 12 parts. So what I'm going to do, first of all, is to replace these 3 rods, which are 30, with 31s. So now I have 30 units or ones, but remember I had 8 from before. So together I have 38 units or ones. Can I now try to put this into 12 groups? Well, I can try. What I'm going to do is I'm going to start with 3. So boys and girls, we have our 278 okras represented using our base and materials, and we have them divided into 12 sets, which represents the 12 bags. What I'm going to do now is to use the algorithm to represent the same problem and solve it using the algorithm. I'm going to first use the short method. So I'm going to write 12 into 278. Remember, we begin with division. We begin dividing from the number that is extremely left. Right? So that number here, this is a 3-digit number. This 2 here represents 200. So just to get an estimate, I can look at my divisor, which is 12, and I can look at the first number, which is 2. I can't make sets of 12 with 2, so I put both together. I can make sets of 12 with 27. How many times? And that gives me a little estimate of what number I can try. So 27 can be divided by 12 twice. Remember, this 2 here represents 20. 2 times 12 will give me 24. So my remainder from the 27 is going to be 3, and I'm going to write that 3 right there. So that 3 there is also 3 tens, which is 30. When it's added to the 8, it's 38. So I'm now going to divide 38 by 12. And that will give me 3 sets of 12, which is 36. And I have a remainder of 2. I can represent this another way, still not with the full long division algorithm, but I'm going to use a method called partial quotients. So I'm going to write the algorithm again. And boys and girls, we are getting to that long division. method. 278. So we are going to use a method called partial quotients. We are still not at the long division algorithm yet, but we are getting there. So I'm going to look at the first two numbers, the 2 and the 7, which represents 270. And I'm going to see how many sets of 12 I can get in 270. And above here, I'm going to write a 2. Now that 2 represents 20. 20 by 12 is 240. I'm going to write that 20 here because it's my partial answer. And I'm going to subtract. I'm going to get 8 take away 0, 7 take away 4. I now have 38 when I have subtracted. So I now have to see how many sets of 12 I will get in 38. Right? I know that 12 times 3 is 36, so I am going to try 3. 3 times 12 is 36. I'm going to subtract that. I'm going to write that 3 here again because it's the part of the answer. And here I have a 2. I can do nothing further with this since this is less than the divisor. So 2 is the remainder, which is the same thing we got here, which is the same thing we got when we modeled our problem using the base 10 resources. So the answer to 278 divided by 12, it's 23 with a remainder of 2. Therefore, there were 2 okras left. Remember to read your questions carefully, boys and girls. We were not asked the number of okras in each bag, but we were asked how many okras were left. Let's look at our final question. A school library has 24 shelves with an equal number of books on each shelf. There is a total of 2,520 books, of which 360 books are on loan. An equal number of books was removed from 12 shelves for loan. What is the total number of books left on these 12 shelves? So boys and girls, this problem is a little bit more complex and it has a lot more information. So we have to try to look at the problem and using our 4-step model, try to get our answer and our solution. So we're going to begin looking at the problem. First of all, it's a school library and it has 24 shelves. The 24 shelves, on each of the 24 shelves, there's the same number of books. So we have this very important word here telling us there's an equal number of books on each shelf. The total number of books in the library is 2,520. But of that 2,520, 360 books are on loan now. These 360 books were removed from 12 shelves, but an equal number of books was removed from each of the 12 shelves. And our question is, what is the total number of books left on these 12 shelves? So we're going to solve this problem in 4 steps. And our first step, we will have to find out how many books are on each shelf of this library before any of the books has been removed. So this is where our division comes into the problem. So I'm going to set up the division. And this time we are looking at a 4-digit number. So, total number of books is 2,520. I will have to divide that by 24 to find out how many books are on each shelf. I'm first going to use what we just used, the partial quotient, and then we are finally going to do the algorithm, which is not very difficult. Right. So, the first two numbers here, the 2 and the 5, really refers to 2,500 or 2,500. So I can say 25 divided by 24 is 100. I'm going to put my 100 here because this is my partial quotient. So 100 by 24, it's 2,400. I'm going to subtract, and I'm going to be left with 120. Can 120 be divided by 24 without any remainder? Maybe we can try the number 5. Right, so 24 by 5 will give me 120. But this 5 here is 5 ones. Therefore, I have no tens there, and I have 5 ones. 5 by 24 is 120. When I subtract, I get no remainder. And this is my partial quotient. And boys and girls, I am now simply going to do this over using what we know as our long division algorithm, and it's very simple. So boys and girls, we are now going to go to our long division algorithm, which you are familiar with. So we begin with the first 2 digits, 25. 25 can be divided by 24, and I'm going to get 1. 1 by 24 is 24, and I'm going to subtract that from the 25. I am now going to bring the next digit down, which is the 2. I cannot get a set of 24 in 12, so I am going to say 12 divided by 24 is 0. I will now bring the 0 down, and I have 120. 120 can be divided by 24. We will get an answer of 5. 5 times 24 is 120. And this works out when I subtract to 0. So this is step 1 of my problem. And the first step we worked is to find out how many books are on each shelf in the library. And our answer is 105. Right. But we know that 360 books are currently on loan. And those 360 books were taken from 12 shelves. Equal numbers were taken from 12 shelves to make up the 360 books. What I want to find out is how many books were taken from each of those 12 shelves. And that's going to be my step 2. And that It's not very difficult. So I'm going to divide 360 by 12. An equal number was taken from each of the 12 shelves. Now, boys and girls, this is another division. But I expect by now that you can use your mental skills to solve this problem. And I don't need to go to another full algorithm. I know 36 divided by 12 will give me 3. Therefore, 360 divided by 12 will give me 30. So what is 30? 30 is the number of books that were removed from each of the 12 shelves and that were given out as loan. Our step 3 of this problem is to find out the number of books that remain on each of these 12 shelves. And again, that's another very simple step. We know that there are 105 books. Even before books are given out on loan, there are 105 books on each shelf, and there are 30. And that 30 are now removed from each of the 12 shelves. So in those 12 shelves, we can subtract 30 from 105, and again, your mental math skills should help you to work this. I could remove the 5, and I could take 30 from 100 and get 70, and then add back the 5. So I will get 75. So 75 books are left on each of these 12 shelves. And my final step, step 4, what I'm being asked in the question is the total number of books on all 12 shelves. And I can now find that out. I can multiply 75 by 12. And again, I can use my mental math strategies to work this out. 75 by 10 will give me 750. 75 by 2, 150. 750 and 150 will give me 900. So the total number of books on the 12 shelves is 900. This is what we were asked to find out. The number of books, the total number of books on the 12 shelves. And the answer there is 900 books. And that's our answer. So boys and girls, today we looked at division. We learned a lot about division. We learned about the types of division. We learned about some of the strategies that we can use to solve problems involving division. I hope that you will try some of these strategies wherever you can find division problems. Try them and see if you can use some of these strategies. Even try sending a problem to your friend and see if they can work it using some of these strategies. So thank you for joining us, and see you again. Bye.